Hello, everybody. Welcome to your Topic 7 Ticket to Retake. This video will serve as a review, a reteach, a way to check your answers. Just use this however it will help you best for retaking the test. All right, so number one, it says to use triangle ABC. Over here, what we have is a right triangle, and we are given all three sides of this right triangle. If we were missing a side, so for example, if we didn't have, let's say, this bottom side right there, and we had to find our trig ratios, sine, cosine, tangent, and then our um, other three, the cosecant, secant, and cotangent, we would need to know what this third side is right here. We can find the third side of a right triangle using Pythagorean theorem. Pythagorean theorem, a squared plus b squared equals c squared. You would just need to make sure that your hypotenuse, which is the longest side opposite of the right triangle, so that would be this one, that is what we use for our c value. So just to run through Pythagorean theorem, because a problem like this on the test would probably only give you two sides of the triangle, so I quick took one away. Um, so a squared plus b squared equals c squared. So 12 squared plus, we don't have our side b, equals c squared. This, the hypotenuse has to be c. So a squared plus b squared equals c squared. We have 144 plus b squared equals 169. And then we subtract 144 from both sides. So b squared is equal to 25, and then we square root both sides and we get the 5. So just a quick reminder on how Pythagorean theorem works. So this is 5. All right, so we need to evaluate the 6 trig ratios for angle A. So we are going to focus on angle A. Maybe I will erase that over there. And I actually want to circle angle A. We want to label our triangle with our three sides, the opposite, the hypotenuse, the adjacent. So the opposite side is the side that's across the triangle from angle A. That's going to be this side BC right here. That's the opposite side. The hypotenuse is going to be across from the 90-degree angle. That's the 13. And 12 will be the adjacent side. Adjacent means next to, so it's the angle that's next to, I'm sorry, it's the side that's next to angle A, but it's not the hypotenuse. All right, so when we do our sine, cosine, tangent, we are going to remember SO, CA, TOA. So we can abbreviate that. Our sine function is equal to the opposite side over the hypotenuse. So there's the SO. CA, cosine, is equal to the adjacent side over the hypotenuse. And then TOA, our tangent function, is equal to the opposite side over the adjacent. And so now it's just a matter of setting up those trig ratios. So sine of angle A, we need the opposite over the hypotenuse. So the opposite side we said was 5, hypotenuse is 13, so this is just going to be 5 over 13. Cosine of angle A is the adjacent side over the hypotenuse. So the adjacent is 12, hypotenuse is 13. So the ratio will be 12 over 13. And then tangent is the opposite over the adjacent. We can see the opposite side is 5, the adjacent side is 12. So those are our three basic trig functions, sine, cosine, tangent. And then we learned about our three new trig functions. These are our reciprocal trig functions to sine, cosine, and tangent. So all we have to do is find the reciprocals of these trig ratios for our three new trig functions. So cosecant of angle A will be the reciprocal of sine. So sine and cosecant, we want to link those together in our brain. So if sine is 5 over 13, cosecant will be 13 over 5, just the reciprocal. Secant will be the reciprocal of cosine. So cosine is 12 over 13. Secant will be 13 over 12. And then cotangent will be the reciprocal of our tangent. So we will just take that 12 or 5 over 12 and find the reciprocal of 12 over 5. So there are our 6 trig functions for this triangle right here. All right, moving on to number 2. What are the trig ratios of theta in a right triangle with the given value tangent of theta is equal to 7 over 24? All right, just to save room, I am going to erase this because I want to draw this out. So anytime that I'm given information and I don't have a picture, I'm drawing out a picture. I know it's going to be a right triangle. So there's my right angle. We have theta. I'm just going to put theta in that spot right there at this angle of the triangle. It could have been this one. It just won't be the right angle. It's one of the other two angles. And then when we're told that tangent of theta is equal to 7 over 24, this 7 over 24, they're giving us two sides of this triangle. So what we want to remember is that tangent is the opposite side over the adjacent side. So they're giving us the opposite side, 7, and the adjacent side, 24. So if I come to this triangle, here's theta, the opposite side is going to be this side over here. So now I know that this side of the triangle is 7. The adjacent side is not going to be the hypotenuse, but it will be the side next to our theta. And that side is 24. So now we just need our hypotenuse. We need our third side of our right triangle, and then we can run through those 6 trig functions again. When you need to find a missing side of a right triangle, you can use Pythagorean theorem if you know 2 sides of the right triangle, which in this case we do. So we can just do a squared plus b squared equals c squared. Our side c is what we're looking for, the hypotenuse, so that's the one we don't know. So a squared, 7 squared, plus 24 squared equals c squared. Now when you do all that math, you will find that c is equal to 25. So same Pythagorean theorem like we worked through above. I would definitely run through it. Make sure you do get a 25 for the hypotenuse. All right, so what we want to do next is label our triangle with the opposite, hypotenuse, adjacent. So opposite of our angle theta is that side 7. So this is the opposite side. 25 is the hypotenuse and 24 is the adjacent. And now we'll just go through SOHCAHTOA for sine, cosine, and tangent. So our sine function is the opposite over the hypotenuse. That's going to give us 7 over 25. Cosine is the adjacent over hypotenuse. So that's 24 over 25. And tangent, we already wrote out, is the opposite over the adjacent, so 7 over 24. All right, then we have our reciprocal functions. We're just going to take the 3 we found and do the reciprocal. So cosecant is the reciprocal of sine, so that's 25 over 7. Secant is the reciprocal of cosine, so 25 over 24. And cotangent is the reciprocal of tangent, 24 over 7. All right, number 3. A kite has a string that is 300 feet long. The flying kite forms a 62-degree angle with a horizontal line running parallel to the ground. The bottom end of the string is 6 feet off the ground. How high is the kite? Round your answer to the nearest tenth. All right, so let's draw this picture out. We have a kite. That's just flying in the air. It forms a 62-degree angle with a horizontal line running parallel to the ground. So here's the ground right here. we've got a horizontal line running parallel to the ground. So what this is doing is it's forming here's the line running parallel to the ground, and there's the 62 degrees. The bottom end, oh, it tells us the kite has a string that is 300 feet long. So this is the kite string. It's attached at this end, and here's the kite string. They're telling us that is 300. And then it says that the bottom end of the string is 6 feet off the ground. How high is the kite? So here's the string, here's the bottom end of the string. So this right here is 6 feet. And the question is, how high off the ground is the kite? So if we look at the kite, we can form a right triangle with this triangle right here. So we're going to start with this triangle, and then we will bring in that 6 feet in the very end. So to figure out how high the kite is off the ground, we need to know how long this is, and then we will add on that additional 6 feet that it's still off of the ground. So we're going to figure out this part of the triangle. So we're trying to find the side of a right triangle. So Pythagorean theorem would be awesome to use. However, you can only use Pythagorean theorem if you know two sides of a right triangle. We only know one side of a right triangle, so we cannot use Pythagorean theorem. Another option, which is the next two problems, I can see we're going to head into special right triangles. Um, if that, if we had a special right triangle, so a 30, 60, 90 triangle or a 45, 45, 90 triangle, those triangles have relationships between the sides, and we could use that to find a missing side. But we don't have a special right triangle, so what we're going to do is use a trig equation. So what a trig equation is we're going to look at our picture, we're going to label the side that we're trying to find, and we're going to determine which trig function will help us solve for x. So what we do there is we say, which two sides of the triangle are we working with? The hypotenuse is 300. So we want to use a trig function that uses hypotenuse. So that narrows it down to sine or cosine. And the side that we're looking for, this is the opposite side from the angle that we know. So we know this 62 degrees. This is the opposite side. So which trig function uses the opposite side and the hypotenuse? And that trig function is sine. So ka toa. The sine function is equal to the opposite over the hypotenuse. So the trig equation that we write is sine of our angle, so sine of 62. That's a number that has a value. We could type that into our calculator to see what the value is. We're going to set that equal to the trig ratio, the opposite over the hypotenuse. So the opposite is x, the hypotenuse is 300. Now we have an equation where we can solve for x. So when I said a minute ago, we need to set up a trig equation. This is what I mean when I say a trig equation. We have some unknown. It is an equation with an equal sign, and we're using sine, cosine, or tangent. So to solve for x, I'm going to think of this as being a fraction. The reason why I like to do that, it just lets us cross multiply to get out of this fraction pretty quickly. 1 times x is x. Sine of 62 times 300. I'm going to write the 300 first. I like to put that out front. 300 times sine of 62. And then all we do is we grab our calculator and we type in 300 times the sine of 62. We do want to make sure that our calculator is in degree mode. It does default to radian mode anytime that it gets reset. All right, so I just typed that into my calculator, and what it says, round to the nearest tenth. So I got 264.9 feet. So we just figured out that this side of this triangle is 264.9 feet. The question is, how high off the ground is the kite? So we just have this additional 6 feet. I'm just going to transfer it over here. So this 6 feet over here is the same as this 6 feet over there. So we just have to add 6 to that. Adding 6 will tell us how high the kite is off of the ground. So our final answer is going to be 270.9 feet. All right, next problem. Here we have, it says find each length. So the length of the hypotenuse of a 45, 45, 90 triangle with a leg of 12. All right, so again, I'm drawing this out. I'm always going to draw everything out. So a 45, 45, 90 triangle, when those angles are the same, the 45 and the 45, this is an isosceles triangle, which means our two legs will be the same length. This leg right here will be the same length as this leg, and then we have our hypotenuse right here. So they're telling us that when it says with a leg of 12, that's how long the leg is. And we know that they will both be 12. If they gave us one, we're getting the other one as well. So 12 and 12. The hypotenuse has a relationship with the leg. If you know what the leg is, the hypotenuse is just going to be the leg times a root 2. So let's just maybe write out in words. The hypotenuse is equal to the leg times a root 2. So there it is. If we can remember the relationships between these sides of your special right triangles, then it can be pretty quick to figure out these answers. Number 5, it says the length of the longer leg. We have to find the length of the longer leg of a 30, 60, 90 triangle. All right, so I'm going to draw this out. This one will not be isosceles. There's the 90. The smaller angle is your 30 degrees. The larger angle is your 60. So 30, 60, 90, and it says that the hypotenuse is 14. All right, so in a 30, 60, 90, there are a couple relationships to remember. And they all have to do with the short leg. The short leg has a relationship with the hypotenuse, and the short leg has a relationship with the long leg. So if this is the hypotenuse, one of these is the short leg and one of these is the long leg. Depending on how accurately you draw your picture, it might be easy to spot the short leg or it might be kind of tricky to spot the short leg. All you have to do is find your 30-degree angle. If you go across the triangle, that is the short leg. So I'm just going to label, that's the short leg across from the 30, which means the long leg is across the triangle from the 60. All right, so I said that there are some relationships we can remember. The short leg is equal to half of the hypotenuse. So that's the relationship between the short leg and the long leg. Short leg is half of the hypotenuse. So if you know the hypotenuse, we're just going to take half of it to get the short leg. So our hypotenuse is 14. The short leg, half of that is 7. So we've got our short leg. All right, the long leg has a relationship with the short leg. The long leg is equal to the short leg times a square root of 3. So if we know that the short leg is 7, the long leg is the short leg 7 times the root 3. So we found, well, I guess what was it asking for? Find the length of the longer leg. So we found the length of the longer leg right here. Short leg, long leg. The short leg is equal to half of the hypotenuse. The long leg is equal to the short leg times the root 3.